Hello everyone, Jeanette here. Today I wanted to review in detail the rock cycle and how the different types of rock form. The rock cycle itself is a description of the interactions of geological processes and how rocks are altered as a result. Let's start with the basics. The three types of rock are igneous, sedimentary, and metamorphic rocks, and each type formed over millions of years. Igneous rocks originate from magma. Magma forms in several ways within the Earth's crust, but the main cause is an increase in temperature and/or a decrease in pressure, allowing the rock to melt. The magma then pushes its way up through the crust, melting the surrounding rock bed as it goes, and will eventually crystallize into solid igneous rocks. Each body of magma has a different composition of minerals that, in general, are either felsic or mafic. So what is the difference between the two? Felsic rocks are comprised of less dense material and are light in color, while mafic rocks are denser and dark colored. The individual characteristics of an igneous rock is determined not only from the minerals they are comprised of, but where they are formed. Extrusive igneous rocks cooled quickly on the surface outside of a volcano or volcanic vent. Extrusive igneous rocks have extremely small crystals due to how fast they are crystallized. Rocks that cool slowly deep within the earth are classified as intrusive igneous rocks. They have large crystals, visible to the naked eye, and can develop into gigantic structures called plutons. Magma chambers that have since gone inactive and dormant create numerous intrusive structures such as batholiths, sills, and dikes. These are exposed through the processes of erosion and through weathering will be broken down into sediment. This takes us into the next type of rock. Sedimentary rocks formed by the lithification of sediments. A combination of mechanical and chemical weathering of pre-existing rocks result in erosion, wind, water, and glaciers, to name a few erosive agents. The subsequent sediments are deposited within various environments. The features of a sedimentary rock are shaped by the environment of deposition, whether it be oceanic, continental, or within a transitional zone. The size of the sediment grains are a result of high energy or low energy environment. Larger grains for high energy and smaller for lower. Sedimentary rocks can be separated into three types: detrital, chemical, and organic. Detrital rocks are formed from sediments that have eroded, and chemical sediments are deposited from evaporation. Organic sediments consist of the remains of once living organisms such as plants and shellfish. Each type of sedimentary rock is subject to cementation and compaction. As the sediments are pressed together, they create layers or strata, with the oldest deposits on the bottom and the newest on top. Sedimentary rocks are very useful as they hold a geological snapshot into ancient landscapes and ecosystems. However, sedimentary strata can be disrupted through geological processes to transform into a different kind of rock altogether, which brings us to metamorphic rocks. Metamorphic rocks form when other types of rocks are changed or undergo metamorphosis, from being exposed to high temperatures or extreme pressure. Every metamorphic rock has a parent rock or protolith, and it can be any other type of rock. How much a rock changes is measured by the metamorphic gradation. Rocks that have endured extreme heat and/or pressure will change more drastically than those exposed to less. One thing to note is that a rock must remain solid. If it melts, it becomes magma instead. There are many types of pressure that will mold a metamorphic rock. Confining pressure squeezes the rock from all sides, and differential pressure is applied unevenly, or compressional pressure causes the individual molecules to stretch. This can produce large variants of foliation within a particular rock. Foliation is the planar arrangement of minerals within a metamorphic rock, though not all metamorphic rocks exhibit this characteristic. The majority of metamorphic rocks form in regions affected by plate tectonics such as oceanic ridges, fault lines, and mountain ranges. Ideally, the cycle will follow the order that we just discussed. Igneous rocks form from solidified magma, then after many years of erosion turn into sediment. From there, the sediments lithify and turn into sedimentary rocks, and after being exposed to heat and pressure will change into a metamorphic rock. Yet, like many of nature's systems, it's not a clear-cut path. At any time, one type of rock can shift into another. For example, a sedimentary rock can be melted and turned into magma, converting it back into igneous rock. Or likewise, a metamorphic rock could erode again into a sediment and become a sedimentary rock. Rocks are not set in proverbial stone. there's your geology joke. The important thing to remember is that the Earth is constantly changing. This has been my rock cycle presentation video. Thank you for watching.
Check the God's simple, she love me, even if I look like